we've looked previously at the group distribution, and we saw an example where you had 100 models and their heights in centimeters were listed in a large table. Then you put them in groups. Alright? These are the groups. Now, each group is also called a class. So you had the 150 to 154, and there were 8 of them in that group, or that class. 155 to 159 centimeters tall, or the height, and there were 16 of them, and so on and so forth, right? Now, what we want to look at are the class interval, the class limits, and the class boundaries, both the lower boundary and the upper boundary. Now, the class interval. Let's look at the first class, this one here. When you look at it, you see these numbers, 150 to 154 centimeters. Or you know that it's centimeters already, right? Now the figures 150 to 154 give the class interval. So the class interval for the first class is 150 to 154. That's the class interval for the first class. Alright? What about the second class? The class intervals for the second class. This one is just the figures again, 155 to 159. So those are the class intervals. Now, for the class limits, in the first class you have the lower limit. The first class, the lower limit is the lower number, 150. Alright? So it's just the n numbers that are the limits. The lower number is the lower limit. Let's look at the first class again. Upper limit. The upper limit for the first class is 154. This. So you have lower limit 150, upper limit 154. Okay? The class interval is 150 to 154. For the second class, the class interval is 155 to 159. You see that? So, those are the class intervals. Now, let's talk about the class boundaries. Alright? We want to know what is the boundary, the upper boundary, as well as the lower boundary for the first class. Since we're dealing with the lower one first, let's put it before the upper boundary. Now, for the first class, what is the lower boundary? Let me erase this first. The thing is this. If you were measuring these persons and you had a measurement of 154.3, would you include that measurement? Not 154.3. I'm looking at the first class, 149.3. would you include that measurement in the first class? Remember, in the first class, in these classes, you have measurements to the nearest centimeter. What is 149 to the nearest centimeter? Remember, you're rounding off. You would not include 149.3. So let me strike that out. That can't work. What about 149.4 centimeters? Would you include that measurement? No. To the nearest centimeter, you would round this back down to 149. So I strike that out. Can't work. What about 149.49? Would you include this measurement in the first class? No, because this would be rounded back down to 149. So I strike this out. Can't work. What about 149.5? Yes, because you would round this up to 150. Alright? You round it up to 150. Good. You could go 153 point whatever, 0.7. You could go up to, suppose you had a measurement of 154.49. You would still include this in the first class because you would round it back down to 154. Alright? Suppose you had 154.5. Would this belong in the first class? No. This would be rounded up to 155 and be placed in the second class. So this cannot work in the first class. Strike it out. So guess what now? For the first class, remember it's the first class we're dealing with here. The lower boundary is 149.5, while the upper boundary would be, in this case, you could say 154.499999. Well, you could go all day talking about 0.499, all the nines you want. But let's just say that if you should measure as tall as 154.5 but just miss the 154.5, the upper boundary is anything less than 154.5, any measurement less than 154.5. Because remember, once it touches 154.5, you round it up to 155 and it goes in the second class. So, here now, let's put everything together. The lower boundary for the first class is 149.5. Now the upper boundary for the first class is less than 154.5. Again, remember, you could have measured as low as 149.5. You could also have measured as high as a value less than 154.5. Right? You could have done that. And you would still include these values you would include these values in the first class. Alright? I don't know why my computer keeps doing this. Just erase what I had a while ago. Let me write it again. Alright. So, anything less than 154.5, you would round it back down to 154 and include it. Now, once it touches 154.5, you would round it up to 155 and you would put it in the second class. Alright? So these are the things that you will do. So, you get the idea? The lower class boundary is 149.5 and the upper class boundary is 154.5, less than 154.5. Now, let me do something a bit different now. The second class, I want you to pause the video. Let me just erase these. I want you to pause the video and then tell me what is the lower boundary for the second class and also the upper boundary for the second class. And guess what? Do it for the third class as well. Alright? The more the merrier. So pause the video and do that now. Alright, so you've done it. For the second class, you had 155 as the lower limit, but you could possibly have measured as low as 154.5 and then round it up to 155. So this is the lower boundary. Alright, let me put the is there. It is. Let me put in my is. Even though this is maths class, we have to get the English correct. The upper boundary is, what is the upper boundary? For the second class, you had the highest number is 159, the higher number 159, but you could possibly have measured as high as 159.49999, or let's say 159.5, but less than that. Because remember, once it touches 159.5, you round it up to 160. But anything less than 159.5, you round it back down to 159 and you place it in the class. For the third class, the lower boundary is here, third class, the lower number is 160, but it could have been 159.5 and then you round it up to 160. So 159.5 it could have been before you round it off. Alright? What about the upper boundary? The upper boundary is, for the third class, you have 164, which could possibly have been 164.4. It could have been 164.49, or any value less than 164.5. Then you round it back down to 164. So it must be less than 164.5. Alright? So you see that these are the upper boundary and the lower boundary. Also notice something. Suppose you take the upper bound, the upper limit of the first class, 154, add it to the lower limit of the second class, 155, equal, divide that by 2, and you get 154.5. Less than that is the upper boundary for the first class, and 154.5 is the lower boundary of the second class. So you could calculate it that way as well. But I want you to reason it out in terms of measurement and rounding off. Alright? Let's look at one more thing here. The width of a class interval. The width of a class interval. What is that? Basically, it is equal to the upper boundary minus the lower boundary. You see that? Let's look at, for example, the first class here. Let's do that. Let's do that calculation. The lower boundary and the upper boundary. The upper boundary is 154.5, so 154.5, anything less than 154.5. Then you minus the lower boundary of 149.5. What do you get? 5. So, for the first class, what you have is 154.5 minus 149.5, and that is equal to 5. Alright? Now, notice, if you just subtract the limits, 154 minus 150, you would not get the 5, you would get 4, which is incorrect. So it must be the boundaries that you subtract. Alright, so these are the boundaries and the intervals. So remember, the class interval is really the numbers that you're looking at. The class limits are the end numbers. The higher number is the upper limit, the lower number is the lower limit. As for the class boundaries, the lower boundary is the lowest value that you could have measured before rounding it up to what you see in the table. And the upper boundary is the highest value that you could possibly have measured, theoretically have measured, before you round it back down and place it in that section of the table. Alright? And then the width of the class interval is the upper boundary minus the lower boundary. Alright, I'll see you in the next video.